If you know the game Valorant, then you surely know how useful Sova's Recon can be. It is a nice way of getting easy kills when enemies are hiding behind objects. So I tried to recreate Sova's Recon, and if you want to know how it works, follow the steps in this video. And also don't forget to subscribe so you don't miss the next update. So firstly, in Unity, create an empty game object, give it a name and reset its transform. Then under it, create a new particle system and give it a name, sphere for example. Then set the duration to 4 and disable looping. Set the start lifetime to 1.5 and the speed to 0 because it doesn't need to move. And change the start size to about 50. Then change the rate over time to 1. Enable size over lifetime and select this curve. Now, set the render mode to mesh, select a sphere and you can see it in your scene. Next, you need to open up your project settings and then in the graphics tab, click on your pipeline asset to locate it and then make sure the depth texture and opaque texture are both enabled. Now, create a new universal unlit shader graph and give it a name. Make sure to enable material override. Then add a screen node and set its mode to raw. We also need a scene depth node with sampling set to high. Then create a color property and a float property called depth. Make sure the color is in HDR mode with a white color and full alpha. Then set the default value of the depth to about 0.5. Connect the screen position node to a split node and then its alpha to a subtract node. Add the depth property to the graph and then remap its value between 0 and 1. And connect that to the subtract node. Subtract the scene depth from the other subtract node. Add in the color property and multiply it with the subtract node. Connect its output to the base color. Split it, connect to the alpha of the shader graph and set the alpha clip threshold to 0. Now create a material out of this shader. Set render face to both and disable cast shadows. And now assign that material to the particle system and when you play it you see it's very bright and we need the intersection color to be white instead of black. So back to the shader graph, add a 1- node and replace this connection. Connect its output to a smooth step node and then multiply it with the color. We now need to access its alpha from the particle system, so add a vertex color node and multiply it with the previous multiply node. Then replace these connections and save the asset. Next, give the material a blue color, set the intensity to 3 and set the depth to about 0.8. And then when the particle system plays, you can see we are getting closer to what we want. So enable color over lifetime and make a fade out to make it look better. Now with some obstacles, you can clearly see the effect. Let me replace these obstacles. And that's when trouble came in because I wanted to use collisions and I tried to use the collision module but the collision bounds repelled each other, so I tried to use the trigger module but it wasn't better. So I tried to use the sphere collider but as you can see the size of the sphere collider doesn't change when the size of the particle changes. So the solution I found was to collect the values of the size over lifetime curve and pass it to the radius of the sphere collider. So for that I created a new C# script and gave it the name Recon. So the script has two references, one for the particle system and one for the sphere collider, then an integer for the particle index. Then on void start I just collect the reference to those components. Then in the void update, if the particle system is plain, I collect an array of active particles. And then if there's more than one active particle, I set the particle index to 1, else to 0. Next, if the particle index is within the range, I find the currently active particle and set the radius of the sphere collider to its size. So after attaching the script to the particle system, make sure the particle index is 0. And now you can see that the radius of the sphere collider increases as the size of each particle increases. Now you need to create another script for the obstacles. We won't need the start and the update method, so just remove it. And then you need to make sure that it detects all the triggers with the tag enemy. So for now it's just going to send a message. So save the script and attach it to the enemies and make sure they both have the rigid body component. Then you need to make sure that you add the tag enemy to both of them. So click on add tag, then click on the plus icon to create the enemy tag and then assign it to the enemies. Also, you need to make sure that the sphere collider of the Recon is set to trigger. and now you can see that it works because it sends the messages. Then download the quick outline asset from the Unity asset store, add it to Unity and add the outline script to both enemies. Select the outline mode and a color, and then if the enemy is hiding behind an object, you can see it. Now back to the enemy script, create a reference to the outline script and on void start assign the outline script. Then replace the debug.log by what actually needs to happen, so that if the outline script is not yet enabled, it enables it. So the last thing is just to disable the outline script on both enemies before launching the game. And this is the final result. So the Recon ability is done, and make sure you subscribe if you don't want to miss the next update. Thanks for watching.